Hi everyone, very good afternoon to all. Today we will discuss one more problem in connection with the force system in space. So in this figure you can see a cube and we have marked the three diagonals on this cube. Diagonal OA, diagonal OC, diagonal OB on three adjacent sides of the cube. Okay, and the force acting on these diagonals are given as OA 500 Newton, OB 700 Newton and OC 800 Newton. So we have to find out the resultant force acting on this cube due to all these forces. So we have already discussed one problem similar to this. So we'll do this also in the same manner. The first step, we have to convert the line of action OA, OB and OC as a unit vectors. The first we will do with the line OA. Okay. So please go through the figure. We will be, for representing the unit vector, first of all we will write the position vector OA, that is from the OA vector starting from the point O and ending at the point B. So we will be representing x coordinate with along with the I component and y coordinate along with the j component and z coordinate along with the k component. So and when we are analyzing the point O and A, the final position of the vector is A and the initial position of the vector is O. So with respect to I, that is x component, the final position is 2 and the initial position of along the x-axis is 0. So along the I component we can write 2 minus 0 or we can write 2I. And similarly along the y-axis, when we are analyzing the point A is along the y-axis, it is making at the point 0 and point O is again at the 0 point with respect to y-axis. So final position and initial position with respect to y-axis of the vector OA is 0 and 0. So for j component we can write 0 j, and with respect to z-axis the point A is at distance 2 meter and point O is at 0 meter. The final position is 2, initial position is 0, final minus initial 2 minus 0, we can write 2k. So the unit vector, position vector can be written as 2i plus 0j plus 2k. So for converting it into unit vector, we will be dividing it with the magnitude 2 square, 0 square and 2 square. So we will get 0.71i, 0j and 0.71k is the unit vector along the direction OA. The next step is to convert it as a force vector. For that we will multiply this unit vector with the force 500 Newton. So we will get the force vector along the direction OA. We will repeat the procedure for OB and OC. For OB, we will analyze in the x-axis. So along the x-axis, the final position is 2 meter. Its initial position is 0. So 2 minus 0 I, and along the y-axis, final position is 2, initial position is 0. So 2 minus 0 j. So along the z-axis, final position is 0, initial position is 0. Because point B is in the xy plane, it don't have any value in the z-axis. So for point B, the value of z is equal to 0. The point O, the value of z is equal to 0. The initial position and the final position of the OB with respect to k is 0. So we can write the equation as 2i plus 2j plus 0k. For converting it to unit vector, we will be dividing its magnitude 2 square plus 2 square plus 0 square. You will get 0.71i, 0.71j plus 0k. To convert into force vector, we will be multiplying with the 700 Newton. So you will get 700 into 0.71 plus 0. So you will get 497i, 497j plus 0k. So repeat the procedure for OC also. Final position with respect to x-axis 0, because point C is lying on the YZ plane. The point with respect to x-axis it is at 0. Point O again it is at 0. So for the I component, we can write 0 minus 0, that is 0i. For the y component, that is k. With respect to y-axis, the final position is at a 2 meter height. Initial position is at 0. So final minus initial 2 minus 0, that is 2j. And with respect to z-axis, the final position is at distance 2 and initial position is at 0. 2 minus 0, 2k. So our equation will become 0i 2j plus 2k. And dividing it by magnitude, 0i 0.71 ij 0.71 k. So converting it into force vector will be multiplying with 800 Newton. So we'll get the value as 569j 569k. And next step to find out the resultant. For getting the resultant, we will add the I terms together. One item, second item, and third one. And we will add the j term together, and we will add the k term together. So we will get the total final resultant. We will add 355, 497. We will get 852. 0 plus 497 plus 567, you will get 1066. 355 plus 569, you will get 924. So this is our resultant vector. And we have to find out the magnitude of the resultant vector. You just take the square of each term and take the square root. Add them and take the square root. So you will get the magnitude. And you have to find out the angle made with the x and y and z axis. For that, you will be dividing the first component, that is 852 for fx divided with the magnitude. So 852 divided by 1648. And for the second one, with respect to y-axis, 1066 divided by 1648. So we get 49.7 degree. And with respect to z-axis, 924 divided by 1648, you will get 55 degree. So you have find out the resultant, magnitude of resultant, and direction of resultant. Okay, we will discuss one more problem in the coming classes. Okay, thank you.